Hello students, let us continue with chapter 12 electricity. We'll be first doing example 12.10. An electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at the minimum. The voltage is 220 volts. What are the current and the resistance in each case? So I'll read it once again and you should be able to write what is given. An electric iron consumes energy at a rate of 840 watt. So we know that 840 watt is power of the body. In this case it is an electric iron. First of all, we know the definition of power. It is the rate at which energy is consumed or transferred. Secondly, even we know that what is the unit of power. So you can easily write P1 is 840 watt when heating is at the maximum rate. And it is also given that the power is 360 watt when the heating is at the minimum. So P2, let us represent it by P2. P2 is 360 watt when heating is at the minimum rate. The voltage is 220 volt. V is 220 volts. We know that if we consider these two cases to be separate, that in each case if we represent the potential differences or voltage by V1, V2, then each of these two will be equal to 220 volts. And hence I have written V is equal to 220 volts is equal to V1 is equal to V2. What are the current and the resistance in each case? It means you have to consider the two cases separately and you have to find the current and the resistance value in each case. So we can write I1 is question mark, R1 you have to find for the case 1 and I2, R2 for the case 2. What is case 1 here? When the heating is at the maximum rate, and case 2 when heating is at the minimum rate. If you want, you can write here case 1 when heating is at the maximum rate, case 2 when heating is at the minimum rate. So now we have this formula for power. P is equal to VI. So we can write it for case 1. P1 is V1 I1 and we can easily find I1 as I1 is equal to P1 by V1. There is no need of conversion. Everything is in SI. So you can put the values and get the answer as 3.818 ampere. We can round it off to 2 decimal places as we usually do. So 3.82 ampere is the answer for current in the first case when the heating is at the maximum rate. Now to find the resistance we can use Ohm's law. So V1 is equal to I1 R1. You can easily find the resistance value in this case as current we have found just now and voltage is given. So R1 is equal to V1 over I1. Just put the values of V1 and I1 and we get the answer as 57.59 ohms. Similarly, for the second case, we can find the current and resistance by using this expression P2 is V2 I2 and Ohm's law. So after putting the values here, we get I2 as 1.64 ampere and R2 as 134.15 ohms. Remember students, you should write the correct unit when you write the answer. When you don't write the unit or write wrong unit, you lose marks for that. I hope this is clear to you. Now let us start example 12.11. 100 joules of heat are produced each second in a 4 ohm resistance. Find the potential difference across the resistor. So let us have the reading once again. 100 joules of heat are produced each second. So given 100 joules of heat. So heat energy capital H is 100 joules. They are produced each second. It means time T is 1 second. In a 4 ohm resistance, so capital R is 4 ohms. Find the potential difference across the resistor. You are supposed to find the potential difference V. Now we know that using Ohm's law to find V, we are supposed to use the Ohm's law. V is equal to IR, R is there and we are supposed to find the value of I, current. Okay, and to find I, we can use the Joule's law of heating, its mathematical form, H is equal to I square RT. So I square is equal to H over R into T. Put the value of H as 100 joules and R and T as given here. So 4 into 1 in the denominator. So after doing calculation, I square is 25 and I is square root of 25. So I is 5 ampere. Current we have found, it is 5 ampere. But we are supposed to find out potential difference. So V is equal to IR is equal to I is 5 into R is 4, 20 volts. So potential difference V is 20 volts. This is our final answer. Example 12.12. An electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? So we can write now what is given. An electric bulb is connected to a 220 volt generator. So given potential difference V is 220 volts. And also it is given that the current is 0.50 ampere. So I is 0.50 ampere and you have to find the power of the bulb. Okay. So here it is a very simple numerical. No conversion required. P we have to find. We have the formula for P is equal to VI. So put the values of V and I from the given and do the calculations. Your answer here is 110 watts. So just write the symbol for watts, capital W. And I have told you, you should write the unit, otherwise you will lose marks. So simple numerical, hope it is clear to you. So now we'll proceed to the last solved numerical of the chapter, that is example 12.13. So I'll read the question, pay attention. An electric refrigerator rated 400 watts operates 8 hours per day. What is the cost of the energy to operate it for 30 days at rupees 3 per kilowatt hour? So I'll read it again. An electric refrigerator rated 400 watt operates 8 hours per day. Okay. So given power of the generator here is, power of the refrigerator here is 400 watt and time they have given, it works in a day for 8 hours. It works 8 hours a day. But as we read the question's next sentence, it is given that find the cost of the energy to operate it for 30 days. 30 days. So total time is not 8 hours. It will be 8 hours into 30, 240 hours. And rate of energy is given as rupees 3 per kilowatt hour. You have to give or find out cost of the energy which is used in 30 days. So here either you can take time as 8 hours and find the energy consumed in 1 day, then energy consumed in 30 days, then you can find the cost of energy. Or here I have written time directly, I have taken it as for 30 days it is 240 hours. So we can directly find out energy consumed in 30 days. Not hours here. Okay. So energy consumed in 30 days. You have to find it out because then only you can find the cost of the energy consumed. Now we know that we are talking about electrical energy and we know the rate is also given of 1 unit of energy. 1 unit means kilowatt hour. It is a commercial unit of electrical energy. So 1 kilowatt hour, what is the value or cost of that? Rupees 3. So energy consumed in 30 days, E is equal to P into T. Why P into T? Because we know power is energy divided by time. So energy is power into time. But as the rate of energy which was expected, as expected it is given for kilowatt hour. So we have to convert this into kilowatt and this should be in hours. So dividing power by 1000 here, 400 watt by 1000, we get the power in kilowatt hour and time is already given in hours. So E is P into T. After we put the values in kilowatt and hour, here after we put the values, the answer for energy consumed in 30 days is 96 kilowatt hour. So what will be cost of this energy consumed? What is the cost of 1 kilowatt hour given? Rupees 3. So cost of the energy here is rupees 3 into 96. That is rupees 228. I hope you have understood whatever we have done in the chapter. First of all, theory part should be clear to you, and then these solved numericals we have done. So we'll continue with the block questions or colored questions which are given between the different topics inside the chapter. After that, we'll do the back exercise, and then we'll have revision of numericals which are not given in NCERT, as in this chapter many different types of numericals can be asked which are not given in NCERT. So please revise the videos and be thorough with the topics and the things, numericals, question answers that we have done. Thank you, students.